There we go. All right, I'm going to start over. So as I just said, I literally just finished my slides the moment this thing started, and I wanted to find out if anybody saw my talk last year on modules. Okay, so you may recall that I promised you that I would have my book done by the end of 2018. I promised it. So I was so sure that last year I bet Dietmar 1,000 to 1 odds that I would finish the book. And I lost. And I paid him last night. Just want to say. So I was serious, but this time, if Dietmar's around, I will offer him 10,000 to 1 odds that it will be done, that it would, only Dietmar, he's special. 10,000 to 1 odds here if he wants to accept it, that the book will be done this year for the same amount of money wagered. But this time it really will be done because last night I finished copy editing for the 3rd time, the final version of chapter 3, which is the first or the last chapter of the first volume of a 3-volume set that's taken me 20 years to write. So that will be out. Accepted. Dietmar is accepted, 10,000 to 1 odds, same amount, which will go unspecified. Okay. So the purpose of this talk is not to convince you, by the way, that allocators are good. We already know that. The question is, are they worth it? That's a different proposition. If there's anybody in this room that thinks that there's no case where an allocator makes the program faster or stops it from becoming slower, there's no hope for you. There's no hope, so forget it. But there's perfectly reasonable people out there that would say, I don't need it. Now, that's a perfectly reasonable thing to say. If you're a large company like Bloomberg, that's not a reasonable thing to say. So we're going to talk about why I think it's a reasonable thing. And then there's a little bit of a tease in here, which I'm not going to talk about because I really don't know anything about it enough to talk about yet. But that day will come. But today we're going to talk about today and what's possible today. So with that, here's the copyright notice. Here's the abstract, which you don't need to read this because you're already here. And the current state of affairs is local allocators imply performance. And we know that from ACCU 17 and benchmarks that are continually being repeated over and over again by many people without looking at the source code, but simply by word of mouth hearing, oh, this is how you do it. They do it themselves. And I believe last year somebody came back having looked at the 2017 talk and did a lightning talk and said something along the lines of just that. So we can go back and look at that thing. There are costs, however, and yet, in addition to the performance benefits, there are collateral benefits which cannot be ignored. Then there remain some concerns. They're in scary quotes. What we're going to do today is present some AA software styles. AA, by the way, is Allocator-Aware. And I can't say Allocator-Aware 2,700 times in a slideshow, so I have to say AA. We're going to separate the real from imagined costs, because there are real costs and there are costs that people think are real that are not real. Or if they are real, they are so infinitesimally small or negligible or unimportant compared to the value that you get that they can be summarily dismissed. There are important collateral benefits that I do want to talk about, and I'll get into those. And then I am going to address these common concerns quickly because they really are not concerns. I'm going to advocate for supporting an allocator-aware software infrastructure in any company that has a substantial amount of development that cares about performance. If you happen to be a video game company, this would go without saying, of course. If you don't really need the performance of C++, you might consider other languages because C++ is not particularly efficient at writing throwaway code. Just a thought. I'm going to make a business case by giving you a detailed analogy. Now, this analogy originally was like, yeah, it's cute, but it doesn't really help. And it turns out that the more you think about it, the analogy is harder than allocators. The analogy is actually really interesting economics. So I bothered to take a lot of time. Last night I left the dinner early. I stayed up all night. I took my little picture that's perfectly obvious to me after looking at it for 2 years and decided to unpack it so you guys could see. So this is more of an economics talk than it is an engineering talk. It's a little engineering. I can't help myself. And then I'm going to hint at why in 2020-something, none of this is going to matter. All right. So here's the outline. And also, by the way, right after this talk, I'm going to run out of here and meet my wife, my new wife. I got married in November, and we're going on our honeymoon. So this is the last thing I intend to do before my honeymoon. So I'm just throwing that out there. Okay, introduction. Dynamic memory allocation is important. We have new and delete. And by the way, rather than give a lot of blah, 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 I'm going to rush through the slides that are not that important because I really do want to get through to the questions and answers if we possibly can, because I'm sure there'll be some. Custom allocation is sometimes advantageous and necessary, but there's a cost to implementing custom allocators. If you've ever tried to do custom memory management or something like that, it's not particularly easy. You need a bit of expertise to do it. And so we're motivated to take a portion of the company and have them focus on making this technology available to application developers today. And we want people who know what they're doing to write the library infrastructure. We want to make it as easy as possible for application developers to take advantage of it. And soon there's this magic thing that I'm not going to talk about really at all until maybe later that will make this all irrelevant. So 2 approaches to custom memory management allocation. There's design it yourself, gives you the best possible performance. It's high development and maintenance cost if an application developer does it, because that means they're not doing something else making money for the firm. And it's not particularly what they should be doing. They should be trying to do something, particularly if you're in finance or you're trying to do something that has a domain experience. Also understanding allocators to the level that you would need to be effective might not be the best use of their time. The alternative is to build allocator-aware components, and allocator-aware components in most cases have nearly the same performance as custom data structures. Almost, not quite, but almost. And in almost all cases, not all cases, sometimes there is no substitute for exactly the right piece. And when that time comes along, for example, if you're dealing with shared memory, don't try to use this allocator-aware software. Write your own special purpose stuff. If you have something, there's something we have at Bloomberg called Datum, and we've given talks at CPPCon and such. This is a very highly specialized, super high performance data structure. It's dangerous. People complain about it or whatever. Doesn't use allocation. It does something even better. And then you can use it as a building block with allocators to make what's called a managed datum. And that thing is actually not quite as fast, but it's a piece to build things together. And hierarchical reuse is the theme of the first book that's coming out, and I strongly recommend that anybody that has any intentions of having a large company last for a long time, look into hierarchical reuse, because when I started writing this 20 years ago, I predicted that this would be a useful thing. 20 years later, it turns out I was right. Who knew? It's much lower cost, by the way, much, much, much lower cost for the developer. Now, I'm not talking about building the infrastructure. The infrastructure has a cost. But when it comes time to use it, it goes without saying that if it's already there and you don't have to write it, it's going to be better for you as an application developer. And then we have these collateral benefits. All right, so now I'm going to go into the most important part of this talk, which has not to do with allocators, but airlines. Everybody knows where this is going, right? Of course you do. It's obvious. So there's first class. What do you think first class is representing? Expensive, good. Anybody else? Why did I pick airlines and why is first class important? What is first class?
Comfortable. The optimal experience.
All right, that sounds good, Kevin. Come on, somebody's got to know.
Low latency.
Low latency is first class. All right, that's not what I had in mind. So let me take a look at this slide. This is a hint.
Great service. High cost. Tailored.
How about bespoke data structures? First class is, that's the best you can get, right? You write it yourself. What could be better than having a bespoke? Bespoke means custom or as needed or ad hoc or just for you. That's first class. The other one is nothing. You get nothing. So that's the other one, and that's economy. So if you're on an airline and you can either have everything or nothing, that's a model of economy. And that's what we had for a while, right? There was once upon a time, there was just one class of service. You get in the plane and you go. Then somebody said, I'm going to use price discrimination. I'm going to put some nicer seats in the plane. Everybody's going to the same place, but a little bit nicer seats, and we'll charge a ton of money, right? That's the difference. Does it make sense now? So economy, low service, but cheapest possible cost. Now we're going to look at this analogy from the client perspective. Here's a plane. You can see this is a very carefully detailed diagram of a plane. Okay, first class is in the front. What do you get in first class? All the wine you want, good wine, right? What do you get in the back? Not enough room to open your laptop. Okay, nothing. But you're all going to the same place, right? Okay, so now imagine, this is where it requires a little bit of thought. Imagine you have this curve. What the heck does this curve mean? So you take all the components that you're going to write in your software world and you order them. You can do this. You personally can do this. You can order them from the components that you could care less about allocators. You could care less about memory management. You wish no one had ever thought about memory management, ever, because it will make absolutely no difference to you, and they couldn't pay you enough money to use it. And then there's the other side of this over here at the 100th percentile, where if you can't have allocators, you're quitting your job and you're going to go hurt somebody. Okay, that's the other side. Now, there's somewhere in the middle, right? There's somewhere in the middle. I wonder where that is. Where you're on the fence. I don't know if I should write my own data structure or not. Will we agree that that exists, right? Does this make sense? This has to be true, right? Because everybody agrees there's some point at which you're going to write your own data structure, even if it's for shared memory, even if it's that datum thing. Some point you're going to do it. So there's some point less than 100%, somewhere. It happens to coincide with the door to first class. Just happens to. We call it alpha. Alpha is this magic point after which you as a developer will roll your own. Does this make sense? Okay. There's a cost to rolling your own. Okay? Now notice we have benefit and cost on the same graph. Some of you will go, this is very important. Where these two things meet, we have demand and supply. No, please forget that. We have two graphs, and there's something important about them, that they line up vertically. But where these two things cross, which you're about to see, cost and benefit, please do not take the intersection point as meaningful. Take the point, the vertical line, as aligning with the door to first class. That's what I'm asking you to do. Because you will try somehow to make something out of this point. You will try. No, don't do that. All right? So this is the cost, right? There's this cost associated with first class. This is a lot of money. This is every time you feel you need a data structure enough to write it yourself, you're going to spend a lot of time and effort and the company's money. Okay. But when you do that, you will achieve this benefit. This is the benefit you get over here for those relatively few. Now, this is not drawn to scale. I want to be clear. This is suggesting that alpha is like 78%. Alpha is not 78%, not today. Alpha is more like 99% or 98%, or if you're in a games world, maybe 50%. You know, like that. Okay, so it is important. It is important because when you need it, you absolutely need it. And it's really, really expensive to do. And you see what I'm saying? So even though it's a few, when you need it, you need it. Okay, so I'm proposing we introduce intermediate grades of seats, business class and premium economy. And so now, alpha minus is the point where if you had to pay only a few dollars more to get out of economy, get a slightly wider seat, maybe get a free drink, maybe a sandwich, you would do it, okay? And then there's alpha plus, which says, I don't need allocators. I'm going to write my own no matter what you do. And those people are going first class because they're Bill Gates and they're, that kind of level. They don't care. And even those people, there's a side benefit, which we'll talk about, which is first class is further away from the exit door, right? It's all the way in the front. So you got to walk a little bit further to get to the door. And that actually is relevant. It's an amazing, interesting analogy that there are lots of things to think about. While first class is clearly better, it's not totally better. There's some things about business class that can be better. Then when I sit in the front seat at business class, because I don't go first class, business class is what my company does, but I get row 1, or whatever the 1 is in business class, maybe it's 8. And I sit in the front because I can get out the door really quick. Okay, so we're going to call the two of them together. I'm going to steal a term from a particular airline. And we're going to call this upper class because you get the same benefit whether you pay premium economy or business class. You get the same benefit because it's the same service, it turns out in this particular case. The lower half of upper class is competing with economy, and the upper half of upper class is competing with first class. Okay, so here's our potential benefit curve. Here's premium economy. Here's business class. Here's cost. And here's how much you have to pay as a client, essentially, if you want to just ignore the fact that we have allocated. We don't care. I don't want to know about it. Don't show it to me. This is not even quite true, but I'm still trying to make an analogy. Whenever there's something in your face to look at and you don't look at it, there's a little bit of cost. You'll get over that. So we're going to call that near zero. Then there are these people that wouldn't have thought to roll their own, but they've always kind of wanted to have just a little taste of performance. You know, maybe they can cut down on the footprint in their room, in their machine room or whatever. Or maybe their clients would be a little happy if it just a little bit faster, be nice. I mean, I don't need it, but be nice. Then there are these people that were going to write their own that don't have to. And those people are extremely happy because now instead of being able to write 1 or 2 data structures, they can write 10 data structures. Except they don't write them, they compose them. And that means that they are 10 times more productive. And they're very, very happy, and they get big raises. This is a good thing. And then there are these people that just are going to do what they're going to do anyway. We can't do anything about them, and we won't want to because they're crazy. They're just crazy people. Okay. We still get the benefit from the crazy people, though that's not hurt. We also get the benefit that we got before from those people spending a whole lot of time. Although they'll do it more now, we'll get this will become bigger because there's more time for them to roll their own. See, they will actually cause alpha to go down. But then we get some actual incremental benefit out of people that would never have done it. You see how this is kind of price discrimination is kind of interesting? I'm really glad I minored in economics because Lord knows it's coming in handy now. And then, what's this thing? What is that? Cost saved. Incremental cost saving of application developers. Whoa. That's a lot of area. That's something. What about this point? Why is this thing tangent here? Does anybody know? How about that point? What's significant about that point? Absolutely nothing. Nothing at all. Zero. The only thing these axes have in common is that benefit is good in some units and cost is bad in some units. But they're not the same units, so where they cross makes no... What are you talking about? You need some sort of conversion function. And everybody's conversion function is different, and the cost is measured in all kinds of things. It's measured in latency. It's measured in programmer effort. It's measured in a lot of things. Okay, so ignore that, but pay attention to these regions. These are important regions. So we get rid of those things, we look at this picture, and now it almost makes sense, right? There's almost some rhyme and reason to this. Does that make sense? Does anybody have any questions here? Because this is the whole talk, we're done. This literally is pretty much the whole talk, we're done. Any questions? Okay. So the next question is, which airline do I fly? It's a test. Which one? It's obvious. Which one? American Airlines. And I'm an American Advantage credit card holder. And you can consider this an AA meeting. I do not want you to forget AA. People make fun of it and say, John, you can't. Yes, I can. Trust me, I can. All right. So we're back to this picture now. Had I shown you the actual picture I wanted to show you, and I didn't stay up last night, imagine if I'd come up and said, here, it's obvious. Oh my God, what the heck was that? But that's what I just explained to you. This is the picture that would have been in the paper, but it was too, I don't know, it was a little too flashy, so I dumbed it down a little bit. By the way, there was a paper. I've been working on this paper for 2 years. I started this paper before I really finished the presentation on performance because I wanted to explain to people why performance is important, but not the only thing. But performance seems to be a very good selling point. But there are other reasons, so we have to pay attention to that. All right. Now, the one thing I didn't have time to do is remove the questions that I didn't have time to write in for this. So you have to come up with your own questions because I don't have any questions. I'll have to come up with that for the next conference. But you guys ask some questions if you have any. No questions? None? Oh, come on. Where is alpha? Where is alpha? Finding alpha. We don't know. But I conjecture that the easier it is for people to take advantage of using allocators and realize just how powerful they are and figure out how to exploit them fully, alpha will change. All right. So there are 4 styles. I was told that I should explain these styles in great detail so that you guys understand them. I am so not going to do that. So there are 3 models, C++ 11, PMR, or C++ 17, that's what you use at Bloomberg, have for 18 years now. And then there's BB20V, which I'm not going to talk about. There are 4 interface styles, C++ 11, BDE, and C++ 17 PMR, and BB20V, which I'm not going to talk about. Okay? C++ 11, it's compile time centric. It has 0 overhead, for real. It really has 0 overhead for the default case. The cons, it's a pain in the butt. That's all I'm going to say. It's a pain in the butt. Okay? Now, BDE style, which is what we use at Bloomberg. BDE is Basic Development Environment or Bloomberg Development Environment, depending on whether it's my book or whether it's Bloomberg. It's the same thing. Pros. There's some really nice things about interoperability with this style. It's just easier. It's easier to use, it's easier to write, it's easier to reason about. It makes sense. The real problem is people think that it has overhead. Now, does it actually have overhead? Yes, it does. It has some overhead. Would you buy a $100 bill for a penny? That's overhead. I mean, it's like, there's overhead. But the overhead is so small compared to the benefit that it's obscene. All right. PMR style is really the same thing, but we wrap the BDE pointer in a wrapper because we like to pass things by value even though they're not value types, because that's what we do in C++. And there's really not much difference, and it's all good. And in fact, we at Bloomberg are going to try to merge back. We forked the standard a long time ago because it wasn't suitable for our needs. And we are working very, very hard to bring it back. And one of the people in London, you may know Vittorio Romeo. He is someone in London you could talk to about BD 4.0 because he is helping tremendously to figure out what exactly that means. BD has been around since 2001 or 2, depending on how you measure it. And it's done a great job, but it is definitely supporting C++ 03. And unfortunately, that's a necessary thing to do when you have people who are application developers and all they can do is have code that works in C++ 03 on platforms that are C++ 03 son and not so good. All right. So there's this thing, language support for the BB20V style. This is vaporware. It doesn't exist. Wouldn't it be nice? We're just going to put this up here. And yeah, that's nice. Well, so no matter what style we have, it's good. It's better to have allocator-aware software in any style. Discussion. If you don't know the different styles, I don't care. I could care less. Seriously. Because if it's allocator-aware, it's good, and if it's not, it's bad. Okay? No questions. All right. Performance benefits. Do I really need to go through this? Does anybody really want to see? I should just skip this, right? I'm going to go through this very quickly. Okay, so they arise from two things: faster allocation and improved memory access. How important is it to be able to allocate and deallocate memory quickly? How many people think that's important? Okay. How many people think, yeah, it might be important sometimes, but really the most important thing is the access of the memory that's allocated? Okay, all of you people are absolutely right, and the first people are mostly wrong. Access is everything. The cost of allocating memory is nothing. If you don't believe me, try writing a system that doesn't fit in your working set. That's all you have to do. I can tell you how to do it. Pablo Halpern can tell you how to do it. Alistair Meredith can tell you how to do it. There are a number of people at Bloomberg that can tell you how to do it. But once you do it, you're done. You'll see an order of magnitude slow down due to something called diffusion. Which dominates? Short-running programs, faster allocation calls matter. You can do cute things. If you build something up, touch it once and get rid of it, allocation matters if you do that a lot. But if you build something up and then it kind of gets to a certain state and then you access it and you slowly morph it into something else, using moves maybe, not good. So long-running programs, improved memory access is the only thing you care about. And I mean, the other doesn't matter at all. Now, you may find this hard to believe. You'll go home, you'll write some small test. You go, see, look, this is faster. No, that doesn't matter because micro benchmarks are not your friend when it comes to paging. They're not your friend when you're trying to look at caching effects. You need to write something that's big enough so that when you go here, there's not enough memory. Then you go here, then there's not enough memory. Then you go here, then there's not enough memory. Whereas if all the memories together, you're going here, 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 and there is enough memory and it works. Please take that with you. How fast you allocate and deallocate is a secondary property of memory allocators. The access that you get from it is the only thing you care about. In fact, even benchmarking the access requires us to touch only a tiny portion of the thing that we allocated, lest the allocation dominate the benchmark. Okay, common use in pattern 1, build up a data structure, use a monotonic allocator. Now, did anybody go to the talk yesterday? It was an excellent, that was a serious talk. You need to see it on video. In fact, we need to make a paper out of that talk and we need to publish it. Just saying. See that talk. Was it beyond, well, who's the name of the person? Are you here? What's your, say? Andreas? I'm sorry. Andreas's talk yesterday, really, I swear, for just writing an allocator, that's it. That's the stuff. You've got to see that on video. So yesterday, was it, it was the second to last session, was it? Right after lunch. The right after lunch session yesterday, Friday. See it. Awesome. All right, so you use the monotonic allocator, and he explained exactly what that is perfectly, and I'm not going to do it here because that'd be a waste of everyone's time. Common pattern 2, and this is the benchmark 2 in Lakos ACCU 17, and you use a multi-pool allocator. He explained that awesomely, and it's really just works, and it's all good, and I'll put that up here. And common usage pattern number 3 is we need to create some data structure, and instead of using very expensive shared pointers and all these things, because we're so good at modern C++, we use raw pointers and we wink it out, and it's 10 times faster than anything you could possibly write. And so we like that, so we use the managed allocator, and it's all kinds of good things we can do. There's what they tell you, and then what the truth. Okay, so this is locality is like the king, and without going on and on and on, I'm just going to put this up here for you to take a look at. I can't emphasize enough how important it is to make sure that you have good locality in your programs if they're of any size. If your entire program fits in L1 cache, you can ignore everything that I say. Almost. It's not quite true, actually. But let me not get too crazy. Local arena allocators attenuate diffusion. If you don't know what that means, you need to figure out what that means, because that is good. Attenuating diffusion is something you should be doing all day long. Okay. Oh, there's another model. If anybody does threading, I don't know. But there's some good things you can do with allocators and threading, and that's sort of it's a performance thing, but it's also a capability thing. So I'll just put this out there so I can breathe for a second, and I have only an hour left, and I feel like I'm just scratching the surface. So cache line contention, also known as destructive interference, also known as fault sharing, is naturally avoided with allocators. You don't have to do padding. You don't have to do funny stuff. Now, global allocators try to look out for you here, but they do it in less efficient ways. This is the ultimately efficient way. Achieving maximum performance requires some stuff, global knowledge, and a solid understanding. So achieving good results requires you to be smart and educated. Oh, darn. That's why they pay you money. All right, discussion? You make just a big face, Kevin. Aren't you going to heckle me at least a little bit? I feel you don't love me.
Yeah, sorry, it's a transactional relationship, isn't it?
Yes.
Yeah. No, later.
Later, you'll get me? There's more, okay.
Because everything you said makes sense so far, sorry.
Kevin agrees with me. I would take everything I've said with a grain of salt. All right. Any questions? Is it that you don't understand anything, or am I being lucid? Because I don't know. I didn't sleep much last night. It could have been either. It could easily be either one. I don't know. Is it okay? Pace okay? You with me? I really want to be done with this. I'll tell you. I am so done. But I am enjoying myself. All right. So there are costs. This is not fun. These are actual costs. This is real stuff. This is not made up. There are costs. There are two different kinds of costs. There are upfront costs of creating the stuff, getting the planes ready, getting the seats just right. Right? That's a cost. It's borne by the airline company. And then there's that's like plumbing the allocators, making them work inside the library infrastructure. And it's mostly an infrastructure cost. Really, the clients don't care. Do you care how hard they work to build that plane so that the doors between first class and business are just so? Could you care less? All right. Then there are incremental costs of exploiting or ignoring this infrastructure, right? There are costs for ignoring it even. They're small, but they're costs. So there's an ongoing cognitive burden. If you don't have to think about allocators at all, you don't have to think about whether you need them or not. If you just put your head in the sand, that's what you do. There's a burden because you shouldn't be, but you are, and that hurts. And so there's a burden. You admit to yourself that you're not capable of dealing with allocators, so you're not going to look at them. And that's tough. That's a cost. It's an emotional cost. It's borne by most application developers because they don't use allocators. Hopefully, this will be attenuated by the ease with which we'll make it possible for people to use allocators, and they won't bear this emotional burden of having to know that they're not smart enough to use allocators. So we'll get rid of that. Converting an allocator-unaware class to AA. Here's how you do it. It's not really a big deal. For straightforward stuff is pretty much, we have code that just does it for you right now. It's just a preprocessor. Boom, done. Verifies that you did it right. But unfortunately, it's not so easy when you get into interesting types. So templates. Does anybody know why templates would be a little bit harder than your pedestrian attribute type? Like a struct? Why is a template a little harder? Who knows? Go ahead.
Because the type that a template of might need to do allocations itself.
Okay, so if you have a template and the thing that it's parameterized by has to do allocations, your template is managing that type. You don't know whether you pass it or not, and if you do pass it, how do you pass it? So there has to be some communication there, and unless there's some established pattern, it could be difficult, right? So that's a problem. Then there are container types. What's different about a container type above and beyond a template type? Well, okay, it manages its own memory. There's a specific thing that happens with container types, which is that you can add and subtract elements from it. And when you do that, that means that something other than the constructor needs to be aware of the plumbing. So what's interesting is for most types, you don't need to touch any method but the constructors. But for containers, you have to touch append, insert, remove, you got to do some more work. So container types are really a problem. They really require thinking. How about non-allocating templates like pair? Now that's a real mind bender. They don't even have allocators in their interface, and yet they have to deal with things that allocate memory. What do you do with that? Right? Oh, and let's not forget shared pointer. How is a compiler supposed to reason about shared pointer? Seriously, like who in their right mind would write such a thing? That's crazy. Compiler, did anybody go to the dinner last night? You need artificial intelligence to examine somebody's brain. Who would create such a thing as this? This is man's work or woman's work. I don't want to be chauvinist in this day and age, but somebody, when you say something good about somebody, it's okay to do it with a woman, but if you say something bad, it's really bad if you make it, it's not fair. There's some inconsistency there I haven't worked out. Anyway, there's a maintenance burden, and the measurements, by the way, are based on BDE code for 2017. It's about 10% in source code. It's going to get worse because when you start talking about move semantics and such, this is not good. And there's more training involved, and there are opportunity costs, right? Because if I have Alistair Meredith, for example, if he's trying to plumb allocators into the standard in some interesting way back in 2011, when we needed them for unordered containers where they weren't exactly what we needed, this means that he can't be doing useful stuff like developing the next generation of compiler technology so that human beings don't have to do this nonsense. So other important projects might be delayed, like creating a compiler that did this kind of work for you. Who knew? Mitigating factors. Well, this stuff lends itself to automation. We have a tool called BD Verify that can check it. We have this thing that we're thinking about that might be able to do some interesting things that we're not going to talk about, kind of analogous to self-driving cars. Just a question. This is just a thought for now. How much more expensive do you think a self-driving car would be than a regular car once the technology is established? What? Less? You think it's less? Well, all right, I'd be interested to know why it's less. Who thinks it's less? Because I think there's a cost of the software, and the incremental cost of the software is zero. And then there's the cost of the processor that processes the software, and it probably costs $1. And then there are the sensors, but you know how expensive a phone's camera is, so not that much more expensive, right? There's a lot of utility in self-driving cars. So once you get over the burden of being able to master the technology, then you might have something.
John,
Yes?
there is the cost of legislation and insurance.
I'm glad you brought up insurance, because that's going to come up. Excellent. Legislation and insurance. Yes, there is a great cost associated with getting the thing into place. But once it's in place, once you have it, nuclear reactors, there's a lot of insurance, there's a lot of legislation. They produce a lot of energy. Not to be controversial, but self-driving cars are also controversial, right? They're going to put a lot of people out of work. What's kind of interesting is that Uber has put a lot of taxi drivers out of work, and self-driving cars are going to put a lot of Uber drivers out of work. And technology is painful, right? Because this is going to put a lot of programmers out of work if we do this. Or is it? Or is it just going to redirect them to doing more useful work? That's what we have to think. We have to take the drudgery out of programming, just like we have a car, so we don't need 4 people to pull a trailer, or a horse is 4 people to pull a trailer, and we have a car, so we don't need a horse, and those kinds of things. I should have gotten more sleep. Anyway, but you get the idea. So we have this these mitigating factors. So the cost of using this Allocator-Aware infrastructure is comparatively small to rolling your own. Remember, we're looking at the clients. Now, Bloomberg, the clients, and the airline company are the same company. So if we spend a lot of money on our planes and our clients are really happy and productive, we win, right? It's a cost-benefit trade-off. We spend more money in our infrastructure, but then our application developers are more productive. That's the trade-off. Now, some people will say, but you know, allocators get in the way of modern style, and I really like to code a certain way, so allocators are bad. We'll talk about that later. It's certainly much easier than rolling your own. Simply supply the desired allocator construction. Requires some additional testing. If you don't need custom memory allocation, try to ignore it. Don't lose sleep over it, just ignore it. Pretend it doesn't matter. Use and test it normally. It's not there, doesn't do anything. It's a burden. And you can opt in later, right? You can always say, you know what? I'd like to use it. I'll use it now. And it'll be there for you. And you can use it. And then you say, why didn't I use this earlier? All right. So this, you'll still see the features. I mean, there's a trailing allocator argument. There's English contracts that you have to not read. Optionally specify a basic allocator to supply memory. Basic allocator is not supplied in. Default allocator will be used and so on. Although there's a net benefit for those who exploit allocators, the overall net user benefit is less clear. In other words, there are people that will say, because there's more to think about in the interface and I don't want to think about it, this is all gobbledygook to me, I don't want to see it. Now, an optional trailing default argument and some lines of text that follow the purpose of the thing, some lines of text that say the same thing every time, are annoying, but they say the same thing every time. You can find them exactly in the code, exactly where it says it in the documentation, and not read them for the umpteenth time, because they always say the same thing. Another argument could be, if this were automated in some sense, maybe that could be removed from the documentation and become well-known. And then it wouldn't have to be in the documentation, and that would be the case if it were part of the language, which would be a great thing. There's an additional opportunity for client misuse because the object could outlive its lifetime. That's very rare. Because of the scoped allocator model, it's hard to make that happen. It's not impossible, but it's hard. What's much more likely is you'll use a special purpose allocator like a monotonic allocator. You'll put it outside a loop. You'll go happily along your way, allocating and deallocating and allocating and deallocating, and then the memory will run out. Your program will crash. And this happens. This will continue to happen. Every time somebody starts working with allocators, they will do this and it will happen. It won't keep happening because they'll realize that's a bad thing. My program crashed because I did this bad thing. And then they won't do that again. Or we could train people up front how not to do that, like how to drive a car. Don't crash it into a brick wall. All righty. So this is a common problem. So misuse can be catastrophic, in which case it doesn't happen a lot because people learn or they get fired. But it also could be really annoying that people go, oh, look, allocators, I'm going to do this great thing. And at the end of the day, it's no faster. It's just yes. And that happens. And that happens a lot. And why does it happen? Because we don't have training. We don't explain to people, look, allocators are a tool, and you use them where appropriate. And where they're not appropriate, don't use them. And if you're not going to measure, don't use them. Right? If you're not going to test, don't use them. Oh, you want to use them? Then you're going to do. Then it's going to be fine. All right. Some people think it's incompatible with modern C++, and it is. There's some things you can't do. They require non-trivial constructors. That means compiler-generated constructors are not going to work. It's exacerbated by C++ 11 moves, and aggregate initialization is not currently available for these things. Now, when I say not currently available, we have this thing that we have in mind that's going to make all these problems go away. But it doesn't exist, so we're not going to talk about it. The assertion that allocators do not interact with modern C++ move semantics is false. This is just false. This is about as false a statement as any statement that could ever exist in the world, ever. This is false. We'll demonstrate how false it is later in the talk. And we're not actually going to demonstrate. I'm just going to tell you about research that's being done concurrently with this trip to ACCU because it's going to be in the paper. The paper's not done because the paper is concurrent with the talk and experiments are concurrent with the paper. But we have preliminary data that's pretty compelling. Lifetime management issues. So if you allow the productive lifetime of an object to exceed the allocator, you're in trouble. And that requires additional care. Limits the applicability of certain features, such as shared pointer, education tools in governance, legislation, proper training, continuing education, code reviews by properly trained people, which is a cost. You've got to train the people to train the people. That's why you have a job. Developer-facing, static analysis tools, company-wide policies, or governance. It's not atypical of powerful paradigms that you have to teach people. Do you think we ought to teach people how to use C++ contracts by chance? Does everybody know exactly when to use C++ contracts? When do you not use contracts, and when do you just check your input data because it could possibly be wrong, as opposed to contracts, which can never be wrong because you're required to call the thing in contract. So why would anybody do something different? By the way, little side note, contracts are used for checking things that cannot happen, right? Input validation is for things that can happen but shouldn't. That's the difference. If it could possibly happen in any universe, do not use a contract, please. It's only if it can't happen because no sane developer would call you out of contract can you then say, okay, this is a contract check. That's another talk. Boy, does it need to exist, though. There's talk on modules that needs to exist, too, but I can't. I just can't.
Okay, so all these talks that don't exist.
Yes.
BB20V.
Yeah.
Of which we do not speak.
Yes.
You know.
Yeah.
It's the Event Horizon Telescope here. We're getting a lot of radiation around.
Yes.
When we get to talk about black hole.
You'd probably have to ask Alistair, when's the talk going to be made? Is it going to be for CPPCon? CPPCon, September. But that's just talking about it. I'm not promising anything but to talk about it. Okay, so see Alistair's talk in CPPCon. Small plug, but do go. Go to CPPCon, first of all. And I probably shouldn't do this, but as long as we're giving plugs, I'll probably be giving a workshop on how to give talks and how to write 1,000 slides and give them in an hour. And anybody who can do it, I'll waive the fee because it's pretty hard. Okay, real substantial costs exist. Takes a lot of effort. Takes somebody who knows what they're doing, but the incremental cost is modest, and I'm being modest about how modest it is. It's really pretty low for the users, but the infrastructure developers do have to work. Now, if you happen to be an industrious application developer and you want to continue the trend and propagate the infrastructure up, then the cost is more significant. But again, the kinds of things that application developers develop are not unsorted map, for example. That's not typical of what developers develop. That's typical of what Alistair develops, and it takes him a year to test it, literally. So, no. We have a credible value proposition. If we don't have hierarchically reusable allocator-aware software infrastructure, then some application developers will need to write it, and the rest will be forced to do without. This is the fact. There's nothing to debate here. That's what it is. Discussion. Have I been fair so far? Do you think I'm presenting both sides at least a little bit reasonably, or do we still have some, what? Yes or no? No? Yes. I couldn't see. I saw this thumb, but I couldn't tell what direction it was pointed. All right. So I'm trying to be fair because it's better to at least understand what other people's concerns are so that you can destroy them rather than not understanding them, because it's harder to hit them when you don't know where they are. Okay. Questions? All right. So there's some collateral benefits. These are really important things. So as I said, when you're in first class, you're not near the door. And so it takes longer to get out of the plane when it catches fire. So there are some other wonderful benefits, and I just throw them up here. Rapid prototyping is one of my favorites, but here's some ideas. Investing in ultra fine-tuned data structures don't get you those collateral benefits. So think about that. If you go the first-class route, you lose all your fun things, like being able to get out of the plane when it's on fire, and other things you don't get. What do you think about that? Wait, I thought that was the best. That's the best for performance, but you pay a la carte for each of those wonderful things that you want in your a la carte and in your first class data structure. So if you really want your, Ferrari fully loaded, oh yes, that's expensive. All right. So it's low cost and low risk. That's one thing. Select from a suite of existing allocation algorithms, plug into an Allocator-Aware software infrastructure component, measure, tune, repeat as needed. That's all you do. This seems to make perfect sense. If you had all of this stuff ready to go in a standard library, wouldn't that be awesome? Well, you do. You do have it. It's just not as glorious because the standard library isn't as big as I'd like it to be. We have our own custom library, and we extend the standard library. Now, we only recently got PMR, so only recently would we have the opportunity to take advantage of it. Unfortunately, it takes a long time to convert code that was written in the 80s to code that runs on a C++ 17 compiler. I don't know if you know, especially when it's written in Fortran. So it takes time. There's latency there. Now, we talked about in the meeting yesterday about chainability. One of the nice things about BD allocators is that since 1997, they've been chainable, and that really works out very nicely. I say BDE-style allocators because I invented them at Bear Stearns when I was there before I was at Bloomberg. And the functionality of one can be used in another, and here's an example. And it's funny, the same slides, the same topics were discussed in your talk. Right? So you didn't see these slides. You did that yourself. But this is very true. One of the nice things you can do is you can take an allocator and you can put it on the stack and you say, well, wait a minute, I want this to use stack memory like alloc. So you say, okay, I'm going to use a buffer on the stack. Well, what if it overflows? Well, I want it to go to backup memory, which is what a good monotonic allocator would do from the heap. Well, I don't want it to do that because I don't want it to overflow my buffer. So what do? I put an alarming allocator on the other side so that when the thing goes through to call the system malloc, it also sends an alarm to the operator that says, you need to enlarge this buffer size next time you release this because it overflowed. And those kinds of things are so easy for front-end application developers to do that we have a fellow named Paul Williams, you may have heard of, who gives talks about how great allocators are. And when I first introduced them to him, he wasn't so keen on it. Then he tried it, but he has an open mind. He said, you know what, this stuff is amazing. Then he told me that that's the best thing I ever did, and I have 3 daughters. I'm like, wait a minute, hold on, just a minute. Okay, so we have this thing called test allocator. It's being proposed by Attila Ferrer, and it's going to be after C++ 20 goes out the door. I invented this in 1998, and it's been battle tested for over 20 years. If there is a silver bullet, this would be it. Checks for memory leaks. You can log and deallocate calls. I didn't mention the buffer guards. It does that, of course. It does everything. It'll make you breakfast. Test exception safety. It did it before Andre, it was David Abrahams who published the paper on how to do this. This thing was doing it before David Abrahams published that. I want you to know, but I didn't publish it. It's in my 3rd volume of my book, which I wrote before he published that, but haven't gotten it out yet. That's the trouble for not publishing. Anyway, this is good stuff. You should use this if you're using allocators. And it's available. It's open source in the BD distribution. I don't have it here, but there is a BD distribution you can go. I think if you just Google like GitHub and BDE, it will show up, and then you'll go find it, and you'll be a happy person. A really awesome example was a monitor that was created by a fellow named Brock Peabody that I hired from, I say this, he was at a pizza store in Kansas. And he came and he invented, but he really was. And he came and he invented this thing, and it's a wonderful thing for using the interface of the allocator interface in a new way via dynamic cast. And it happens to do these things. And the talk really isn't about it, but suffice it to say it's really cool and really useful and in production in Bloomberg today. And it means that anybody who wants to participate in object-based monitoring of memory usage as opposed to type-based monitoring on an arbitrarily large system in production, can do this stuff, and it just works. So anyway, placement of objects as memory is important. When I came to Bloomberg, the reason that I had created allocators was for performance. I mentioned in my talk that we had models that were created, and it would take, because of the coalescing allocators of the day, it took 9 seconds to destroy the model. Normally, you just let it go out of the program go away, and it would get rid of it. But this time, we're using C++, and it had to coalesce all that information. It took 9 seconds plus on quantify. And so we used local allocators, and we handed it off to the guy, and we just winked out the data structure. And instead of taking 9 seconds, you know what quantify said? Absolutely nothing. It did not show up on quantify. It was gone. It was just like, what? Gone. So that was so compelling that that just changed everything. I talk about raises. I can't even tell you. But at a financial company, when you take something that takes 9 seconds and the guy who's head of, credit derivatives is now a happy person, you become a happy person. So anyway, it's better than placement new because it gives you full control. At Bloomberg, we need to put objects in memory-mapped memory, which is I think it's the last example here. We call it the gmalloc allocator. And so we allocate memory into a memory-mapped region. When we want to swap out our memory, we should swap it out onto disk. And because we have multiple processes that are identical, we can swap it back into any process at the same address space. Now remember, the people using this are not computer scientists, because back in the day, they were lawyers, they were whatever they were. And they didn't care. And is this ugly? It's a little ugly. Does it make a ton of money? Yes, it does. So again, if you happen to make people like Michael Bloomberg money, it's good. It's a good thing to do. So allocators make you money. Allocators are good, right? Sometimes we need to get down to the metal. And so the example that I suggest would be, if you don't like raw pointers, well, there are things like Java you can use. But sometimes the best thing to do is to create a data structure using raw pointers, and then just don't worry about deleting them individually, but just get rid of them. And that works really well. And sometimes, you don't even want to call the destructors for objects. You just want to get rid of them. And some people say, well, wait, that's undefined behavior, right? And we have Alistair Meredith in the room who will verify to any and all who care that as long as you don't access the object after you've stopped giving it ownership of the memory, it's all good. That's allowed. And then there's some weirdnesses in C++ 17 that I will not even mention, that I just shouldn't be allowed to be thought about because they're just too weird. So we will talk about them. Better you not know. Okay, this is basically unbounded stuff. So most of this stuff depends on indirectly on the ability to inject allocators into the system at runtime. It's not really something we use, but because of the syntax of C++, that property gives us some great interoperability. But if we don't invest in the Allocator-Aware software infrastructure, the cost of pursuing any of the benefits that we're looking for is prohibitively large. And so we probably wouldn't do it. So when the time comes, when it's time to run out of the plane because there's a fire, sorry, you're in first class, but John is in business class. He's in the front row of business class, and he's off the plane, and you're on fire. And that's too bad. Sorry. All right, discussion? I have 30 minutes left. I'm actually doing okay, I think. Because this is the part that's, the controversial part is the part where people go, but wait, what? All right. So concerns. We have 30 minutes for concerns. This could take a week. Okay, this is just what happened. This is not an overstatement by any stretch. They really have C++ 98 allocators were not allocators, and that was talked about. And then C++ 03 allocators have weasel words. Pablo can explain what those weasel words were. So in C++ 11, we fixed the weasel words, so at least there was something. And then there was C++ 11, and there was something, and it was a necessary evil on the way to sanity because people couldn't get their mind around polymorphic allocators because the first thing they said was what? Virtual functions calling? Oh my God, you are out of your mind. No, not. Anyway. C++ 17 allocators are exactly that, runtime polymorphic. Just took them some time to realize. Now, I want to ask you the question, do you really think that if allocators were not real, and I didn't prove them, that they would be adopted into the standard? I just have to ask you that question, because it seems to me like getting allocators into the standard is just about witchcraft, because there are a large number of people who do not like allocators, and they would rather never see them and hope they go away and they don't exist and they're emotionally traumatizing and they need mental therapy to recover from the fact that allocators are even out there. So this happened. The reason this happened is we had an intern who was a very bright guy. He just recently left Bloomberg and joined another company, Facebook, I think. Anyway, very bright guy. And I said to him, hey, look, we did this experiment, but we need you to benchmark because we have a clerical error. We had swapped some columns in the first draft. We knew that we had a problem. So I said, here, I'm not going to show you the code. I'm just going to tell you what's going on. Go reproduce these results. He did. He got the same results, and he showed us that the columns were reversed. So revision 1, which is really, I guess it's revision 1 of the paper. I hope I got it right. Might be revision 0 of the paper because it was a new P number. But whatever it is, the most recent revision of the paper has the columns in the right spot. And you can Google it, and it's Alistair Meredith is on it, and I'm on it, Nathan Myers is on it, and not sure who else is on it. Might be Alex. Who else? There are some people on it. But if you get Alistair Meredith and me and the allocators and the standard, we'll be good. Anyway, we were able to reproduce this data. And he came to the standards meeting. He was 20 years old or something at the time. And he said, look, I promise you I didn't do anything. I just tell you, and they all believed him. And it's true. He really did this. And they said, all right, fine. And then at the last minute, he said, you know what? As long as you've got a gun, let's give you some bullets. So he gave us multi-pool and monotonic allocator too, so you could actually use it. That was amazing. I never thought that would happen. You actually, here's a gun, but we're not giving you any bullets. We don't. No. So they did that. So this is a great thing. So you can actually use C++ 17 allocators. That's a great thing. And then people invent reasons for not liking allocators. And here's one that's not so unreasonable, right? We have state-of-the-art allocators are good or better than, maybe that's a reason. Or PMR violates the zero overhead principle, or generally poor runtime performance trade-offs, or unmanageable verification and testing complexity, or gross incompatibility with modern C++, or don't play nice with modern C++ move semantics, or object pools and factories are as good or better. Does anybody find any of these compelling? I mean, seriously, because true story, these were represented to me by the now engineering head of Bloomberg, who I consider to be the best software engineer I've ever met. He's an international chess champion, smart guy. And he told me these things. These are actually from him. And I actually thought he was reporting what other people were saying, but kind of tongue-in-cheek. The way it was expressed was more or less like, well, this is what people are saying. Now, at the time, being 3 levels up in management and not being a C++, modern C++ aficionado or whatever, all he can go on is by all the people that tell him what's going on. It's just not possible. So he was actually saying that these were concerns, and that he shared them as concerns. The way I responded to them first time was not pleasant, and don't do that. When your boss's boss's boss asks you to look into these concerns, don't go back and say they're a pile of crap because it's not good, because he was not. It's okay now. I survived, but it was a bad idea. Somebody have a question?
I just comment. The virtual function call,
Mm-hmm.
taking the lock to get the global pool in the multi-threaded environment is neglectful.
What he just said is the overhead of taking a lock in a global environment is bigger than the virtual function call. Well, that's So that's more, That's true. In fact, let me just summarize this. Whenever you use a local allocator instead of a global allocator that's not designed for single-threaded solutions, you already gained a factor of 4, just right off the bat. I mean, that's just for free, just to let you know. So I agree with you, but I have data. You can go look at benchmark 1, and you'll see a factor of 4 or factor of 5 improvement on nothing, on no access. So yes, that's true. Everybody got that? Just taking the lock from the global allocator, just that, unless you turn off locking, unless you somehow disable the lock on the global allocator, you're already paying way more than a virtual function call. Good point, fair enough. Anyway, we're going to talk about each of these. Is there any one of these that interests anybody, or this is all just nonsense, yes?
I'm concerned about testing complexity. I'm thinking about you writing a library and adding the default allocator parameter to all the constructors, and you submit it to code review, and you forgot to do it in one place, and you got missed in the review.
Okay, so the concern...
You're doing is shared memory stuff you do with Bloomberg.
Okay, but the concern that you have is not so much for application developers as it is for library developers.
No, application developers.
Well, are they also plumbing the allocator-aware infrastructure?
They may do because their API might be being consumed.
All right. So here's the thing. You have the class, right? You have people that have to build unordered map from scratch. That's Alistair. Neither you nor I can do that. Let's just face it. There's only one person in the world who can do that. That's Alistair. So that's not on the table. Now, if you have something that is, let's say, just a struct, a templated struct, both you and I can do that, and we'll do it carefully, and it'll be fine. There's something in between there where application developers wouldn't try, but library developers would try. And if the application developer would try to do it, they would need help to do it, most likely. Now, that's a generalization. But most of the time, application developers don't try to do really tough data structures most of the time. But your point is that when you try to do this, it does complicate things, right? Okay, so I didn't say that this isn't true. I'm saying that this isn't a reason to run scared, run away. This is a reason to be mindful and use the tools available. That's what it is. We're going to get to them specifically, but in other words, does it make testing more complex for anybody who's using this today? Yes, it does. But is it so difficult that we can't think about it? Because if that's the case, there's a lot of C++ that we can't really use. Do you see what I'm saying? This is not worse than a lot of things in C++. I can go on. I mean, this is comparable, but it's not worse than a lot of things in C++. Anyway, I'm going to go through these because we can. So let's read this. Advances in global memory allocation have led to dramatic performance improvements, especially with respect to real-world multi-threaded applications. Would replacing the compiler-supplied global memory allocator with a newer state-of-the-art one achieve most, if not all, of the real benefits derived from assiduous use of local allocator design into a program? Anybody identify, have empathy for people who feel that way, even if you don't feel that way yourself? Does anybody go, no? Yeah, a little bit. Okay, so let me just put the slide up. Global allocators are not and cannot be sufficient. I'm going to put some reasons up why. They're ignorant of your application. They cannot achieve locality that local allocators do. That's really the big one. Furthermore, they can't provide collateral benefits. So they're not a substitute for local allocators in performance or collateral benefits. They can't be, they never will be. They're not even close. So if you believe that, then you need another language because that's not true. It's just not true. You need a language where memory allocation is not important. Zero overhead principle. For all but the C++ 11 model, AA objects require maintaining extra state, even if the most common case, i.e. where the default allocator is used, and two, necessarily employ virtual function dispatch when allocating and deallocating memory. Isn't that too efficient for AA software to be viable in C++? What a bunch of nonsense. Oh my God. So it doesn't violate the letter or the spirit of ZOP. It turns out that there are many ways to recover the extra space. But we benchmarked and decided that we wouldn't do that because if we recover the extra space, there's more computation on the average path. and that's slower than not recovering the space. That's just the way it is. So even though we could save the space, we choose not to. Virtual function dispatch, in the most obvious case where you're building something up, using it and destroying it, you create the allocator on the program stack, you pass the address into the container, you build it up, you use it, you get rid of it, right? That's what happens. The container is a template. The compiler can see its implementation, right? That's number one. The virtual functions of the allocator, the derived allocator that's on the program stack, are inlined, so you can see them. The compiler produces the same code in many cases as if it had invaded the type. This is the world that we live in. This is how GCC works. This is how Clang did not work in 2014, and now I understand it's improved dramatically. But now that allocators are part of C++17, and this is a standard pattern, I promise you compiler technology will rise to the occasion, and devirtualization will become, in these idioms, routine. Okay. Anybody doubt this? I mean, the benchmarks are staggering, and the lock is just a factor of 4 right off the top. Okay. AA software makes prudent design trade-offs. So here's one. Is this a good trade-off? Would you guys make this trade-off if you could? Yeah. How about this one? You like this trade-off? You like it? How about this one? So this is the kind of trade-off that we're loath to make. We do not like making a trade-off where somebody gets screwed, because then they report it to your boss and you get fired. Whereas all of these others are kind of, somebody's really happy, but nobody's really sad. Those are the good ones. The bad ones are somebody's really sad. We did this. We used the short string optimization. By the way, does the short string optimization take up more or less space? Does it waste more or less space in, say, for example, the null string? What do you think? Is the null string a common sentinel that we use sometimes? The empty string, I should say, the empty string. So the short string optimization actually makes strings bigger. The typical implementation of strings in industry, string might have been 3 pointers, now it's 8 pointers, right? It's bigger. That's the way we implement, because it's faster in the general case for our data. So it turns out that this really does blow some people up. If you have a vector of strings, you just 2.5, 3 times as big now. So if you really created a vector of strings and you cared about the size, you should probably think about not working at a company that uses C++. But anyway, but this was a problem. And we had to go to those people and say, look, we understand, but we did this. Anyway, just want to point out that this is what allocators, somewhere between 1 and 2 is what allocators are. And we call it the allocator tax. And now we can get Kevlin Henny's insurance in. Everyone must buy auto insurance. Why? Why? Accidents are unusual, but not rare. Hold on. Right? I got it. I got it. Kevlin has been, what is it, pwned? All right. Okay, not really. I can't do that to Kevlin. All right, failure to properly annotate types or propagate allocators can undermine the effectiveness of the allocation strategy and can lead to memory leaks, especially when winking out memory. Aren't the extensive verification testing and/or peer review required to avoid such errors impracticable? Impracticable means can't put into practice. Okay. No. All right. Every library has issues. Allocators are entirely opt-in. So if you don't want to do it, there's no overhead. That's right off the bat. You don't have to do it. So if you don't have to do it, you don't have to do it, period. There's nothing to do. But if you do want to do it, and you use a special purpose allocator, you can shoot yourself in the foot. Winking out is dangerous. And if you do that and you don't know what you're doing, you will hurt yourself. And static analysis tools like BD Verify can help a lot. The test allocator can help a lot. This other thing, we'll talk about it later. Compatibility with modern C++ style. C++11 encourages a style of programming where objects are more often passed and returned by values, sometimes relying on R value references to move these objects effectively whereby BDE style requires relies on passing AA objects by address as arguments to achieve optimal efficiency and control over the allocator employed. Isn't this old-fashioned style unjustifiably restrictive? Ha! Laugh, laugh, laugh. All right. So custom allocators do not affect function style. What do you think of that? The function style is broken, has nothing to do with allocators. Who knows why? What does the function style have to do with moves? Nothing. Who knew that? We return objects that allocate memory by value. Has nothing to do with move. Did you all know that? News here. It's return value optimization. It's been that way since C++03. And now there's named return value optimization that isn't mandated but suggested. And move is a pessimization and no one does it. And if you do it, you're pessimizing your code. What do you think of that? Okay, the problem is that whenever you return something by value, you have to construct it. If you pass the thing in, it's already constructed. You effectively have created an object pool situation when you use our methodology. You've effectively unpooled it when you use C++11 return by value. Now, somebody tell me why that's good. I know why it's good. It's because people like to write functional-looking programs. It's easier to reason about. And if you're doing application development, there are languages for that. You know, JavaScript is really a perfectly good language. No one should be ashamed if they want to give up C++ and write JavaScript. But if you're writing C++, you should be able to write at the lowest level the fastest code, the most articulate code. And so if you choose to have this functional notation, by all means have it, but build it on top of something that actually runs quickly. Okay. Does anybody want to controvert that some more? Because that's just a fact. There is absolutely nothing to do with move. It has nothing to do with the design. Is none of that. It is we have taken away the ability to have an effective object pool and construct and destruct the object with the default allocator every time. And if you think you're helping things by supplying an allocator argument so that you can give it and imbue it an allocator, you've done nothing. You're still calling the constructor and destructor every time. Yes?
Can you go back one slide?
Yep.
I think the second bullet is wrong in C++17 because we have the return value optimization guaranteed by the language. So the actual returned object is constructed in place at the call side.
My point is, he's saying it's guaranteed to be constructed on every call. You just said that. It's guaranteed to be constructed. You said that. Did you not say that?
Yes.
He admits he said it. It is guaranteed by the language to be constructed on every call. I rest my case, sir.
On the call side.
On every call. At the call site, on every call. I rest my case. In my way, it's not. It's not constructed every time at the call site. It's not constructed at all.
So you have a side effect within the argument.
The argument is created and passed in, and you assign the value without recreating it, which means constructing it, which is an expensive operation compared to just reprogramming it with the value. The value is cheap compared to reconstructing it. Would you agree? That's what object pools do. Okay. Anyway, I understand that, but talk to somebody about the fact that you just asserted, which is that you construct the object every time versus you have a parser, you pass in a string, the string grows to its natural high water mark, and then there's no more construction, there's no more allocation, there's just simply moving, mem-copying the data or putting it into place inside the function so that it doesn't have to be moved or anything. Do you understand? You're literally not doing anything, whereas before you're constructing and destructing, and you're forced to by the language. You don't have a choice. Just think about that that's true, and you said it. And everybody agrees that you're right. I don't know what to say. All right. When two objects are different, use different allocator, move assignment degenerates to copy operations, and swap becomes undefined behavior. Doesn't that imply that local allocators should be avoided to enable such operations? What do you think I think about that? Move is a very bad thing. Move assignment is an awful thing. It has some very limited uses, but if you find yourself using move assignment and then you say, well, I can't use allocators because I like move assignment, talk about the tail wagging the dog. Oh my goodness. So move assignment is often not as efficient as copy. This is something that we are proving now. We actually have benchmarks, and I will publish them. But it turns out that copy, what makes copy exciting is that you copy it once and then you access it for a long time. And because all of the copies are local, they're actually laid out in memory perfectly, not just within a pool, but when you allocated the memory to begin with, you allocated in all the ways that computers like to consume it. They consume it in alternating cache bank order and all that good stuff. They're forward moving, they're local. And so when you go to deal with your working set, it fits in the smallest cache that it can in order and alternating cache banks, right? You know what I'm talking about with those. You want to have access be every other cache bank so that you get the stair step when it comes on the bus. Please tell me you know what I'm doing. If you don't know, it's fine. Anyway, the point is that move screws with that. Now, that's not a problem for returning values on the stack because the stack is the stack. But if you're building something in dynamically allocated memory, and you're allocating it anew from the start when you create your program, you do not want to muck with that data structure by moving things around. You want to copy things around. If it's big, if it's small, it doesn't matter that much. It still matters, but it doesn't matter that much. And that's what I just said. You see all these things that can happen? This is all hardware. And I told you this was an economics talk. So I apologize for the hardware, but that's a fact. All right. Did I go over my time? No, I have 8 minutes. Oh my God, how am I going to use up 8 minutes? Nothing to say. Moving within a container or an arena is okay. It's not great, but it's okay. As long as you're within the arena, as long as you're using the allocator, then it's okay. Yes?
So what if I have, a hierarchy of data structures that only use a good point one allocator, and then I move them around inside that hierarchy. So I still have the right allocator. I still move them around. Would you still say that?
So that's what I'm saying here. If you have an arena allocator, so you have a container, if it's a container, then that's all the same arena. That's like already. But if the arena, yes, if the arena is too big, like global memory, it's too big, no, it's not all right. Because the whole point of the arena is to keep it small enough. If your arena gets too big, then you need to segment your arena. That's a good point. That's fair. What I'm saying is even if your arena is small, even if it's small, if you screw around within your arena, then you lose, you don't lose this, but you lose this, this, and this. And those are second order effects. And I would not recommend anybody go play with their data structure for these. I wouldn't do that. I mean, for these. I would not worry about it for these. But for this, I would. So it's okay here. It's not okay here. And if you're good enough and you know about this, then go ahead and in your object, instead of doing a move, if you know what you're doing, do a copy, if you know what you're doing. But I'm not suggesting that. Again, there are levels that I can suggest, but the only way to know is to measure. Measuring is hard. Really good people don't know how to do it. And I mean this sincerely. Benchmarking is kind of a cross between like science and engineering, and it's hard. Okay. Object pools and factories serve to reduce overhead caused by allocating memory. So why aren't these other approaches as good, if not better, alternatives to allocators? So the funny thing is, it's like, what is it? What did I say once? Do you take the bus to school or do you bring your lunch? Like what? They're not the same thing. Memory allocation is reduced, but it's not obviated, and only in certain cases do moving vans eliminate the need for furniture companies. Oh, I don't know. Anyway, object pools are not replacement for allocators. Object pools are not faster than allocators. They are at different levels of abstraction. Object pools minimize construction, destruction. Memory pools minimize allocation, deallocation. Object pools are created using memory pools. Object pools themselves should typo, I probably have a few. If anybody sees steps, naturally BAA, that way they can participate in the collateral benefits. Does that make sense? So if you build in a hierarchically reusable way and you build them in terms of AA pools, You have less work to do when you create your object pool and you achieve what you wanted to do, which is the same kind of thing that move stops you from doing, which is to use an object pool and not have to reconstruct the object each time as required by C++ 17. Okay. Discussion. Questions. I still didn't finish these questions. I have 5 minutes. Conclusion. Allocator-Aware software infrastructure. Performance, instrumentation, object placement, historically required long delivery time, any collateral benefits cost extra, and no reuse. And I say no reuse because if somebody is an application developer and they build a bespoke data structure, you're probably better off writing it yourself than trying to use that thing. Because first of all, it's not stable, it's probably not been tested, and it's certainly the wrong place in the physical hierarchy to make it useful to use. So these are all problems. AA has real costs. Fixed engineering costs for SI developers, added operational costs for users. There's resistance based on the C++ 11 bad taste that we have. We all know the C++ 11 allocators are horrible, and if you've ever tried to use them, you failed. And if you succeeded, you weren't happy. And if you were happy, you're strange, and so on. Investing in an AASI is an economic decision, provides nearly the same runtime performance, lower incremental costs, be used more often, requires substantial upfront cost, comes with important collateral benefits. The C++ 11 experience caused concerns or FUD, fear, uncertainty, and doubt. And I don't blame people for inferring that from C++ 11 allocators, which were a disaster. But we had to do it. We had to get people to realize that we have to go to the next. It's one of those things, you know? You know the answer, but they must play. They will understand. Do the benefits outweigh the costs? That's what we have to ask each other right now. What do you think?
It depends.
Depends?
It really depends on the alpha value.
It depends on what?
On the alpha value.
It depends. He says it depends on the alpha value. I understand why he says that. I don't think it's so important that the alpha value be a particular number as long as the area under the alpha curve is with the smart people who make the money for the firm. And if we can make them 10 times more productive, it really doesn't matter. But I agree with you that if alpha is bigger, it's better. That's, again, I understand what he's saying. He's also saying if alpha is so high that there are only a couple of people and they're going to roll their own anyway, some people believe that there's only two things. You roll your own or you don't need it at all. I don't agree. I think there's an in-between place where people will spend a little bit to get a lot. And I think that exists. I really do think that exists. But what Vittorio is saying is he's saying that not at an infinite cost. Not at an infinite cost. At a finite cost, at a reasonable cost, it's fine. At an infinite cost, no. Right? Okay. So here's this picture. Wait. How much time do I have? 2 minutes. Oh, shucks. What if it fixed everything? What do you say now? What if there were no cost? Literally no cost. What if there were no cost at all?
Take my money.
Should Bloomberg invest in AASI? How can we afford not to? We're a large company. We've got 6,200 developers, and we do not want them writing bespoke data structures. Any of them. We really don't. The benefits outweigh the costs now, but what about if we had this other thing? What if we eliminate everything, like self-driving cars? There is no cost for the driver. And it reduces client cost to a bare minimum. No documentation, there's no extra argument signature, there's nothing. It looks like basically a virtual function. This is the picture that I actually have in the paper that is incomprehensible, but because you've been to this talk, you are now qualified to read the paper, which is an order of magnitude denser in facts than what you've heard here. And statistics. It's fully referenced. It's ridiculous. It's got more references than my book. Okay, that is it. Questions? I have 39 seconds.
Where do you find your paper?
I'll tell you what, it doesn't exist yet because it's in a, no, it exists in a kind of a nebulous form, but if somebody wants to send mail, oh my God, to me, dare I do this? jlakos@bloomberg.net. If you want a copy of the paper and you send me email, I will try to respond and tell you. I'm going on my honeymoon in about 30 seconds, so I might not respond right away, but I will try to forward that email to a place, and when it's ready to be seen, please don't distribute it widely, but I would love to get feedback, real feedback. So I will say, if you're interested in reading the paper, send me email, jlakos@bloomberg.net, and I will get you a early copy of the paper that will be in a readable form and have the figures cleaned up just a skosh. Okay, I think I'm over. So I'm going to let you all go, and thank you very much for coming.